Chapter 3, Section 2. This is the sine and cosine ratio, Apprentice. So you may have guessed that there are other ratios other than the tangent ratio just by looking at your calculator. Next to the tan button, you'll see a sine button and a cos button. And when we talked about the tangent ratio, remember that was defined. We had the opposite here and the adjacent here, if that's where theta is. And tangent of theta is the opposite divided by the adjacent. So we've already worked with that. But we left out the hypotenuse, and we left that out for a reason. It's because if we want to use the hypotenuse, we use different ratios instead of tan. So for the sine ratio, here's theta. We use the opposite, just like tan, but we don't use the adjacent. It's not needed. But we use the hypotenuse. So we just use a different set of two sides. The sine of theta is defined as the ratio of the opposite to the hypotenuse. All right, so it's set up exactly like the tangent ratio. We're just using a different side. That's all. And the cosine ratio, well, you can probably guess which combination of two sides have we not used yet. Well, we haven't used the adjacent together with the hypotenuse. That's the only combination we haven't done, and that is what cosine is. It's the adjacent divided by the hypotenuse. All right, so it does not use the opposite. All right, well, how do you remember all this stuff? Well, there is an easy way to remember them. Remember when I talked about tangent, I used the word TOA, T-O-A. And for sine, we'll use S-O-H, pronounce that so. And for cos, C-A-H. We could say ka. So we use, this is typically what's used. Okay. SOHCAHTOA. Okay. Say it. SOHCAHTOA. So SOHCAHTOA, the so, that's the sine of angle theta, is the opposite divided by the hypotenuse. The ka, that's cosine, which is the adjacent divided by the hypotenuse. And the toa, well, that's the tangent ratio, opposite over adjacent, and we've already seen that. So now we have 3 ratios in total, and that is it for trigonometry. There are only 3 ratios that we need at this stage. Okay, let's try a couple of examples. It says use the sine or cosine ratio to solve for x. All right, so here's my triangle. My theta is 35 degrees. The opposite is given as 8.4. The adjacent, however, it's not given, nor are we asked to find it. It's this we want to determine. That's x. But if you look, that is the hypotenuse. Remember, the hypotenuse is always the longest of the 3 sides to a right triangle, and it is always directly opposite the 90-degree angle. So which ratio should we use? We want the opposite and the hypotenuse. That is the sine. That's from the so. So the sine of 35 degrees is the opposite. So we do this stuff just like with the tangent ratio, divided by the hypotenuse. There we go. So now the algebra to solve for x is just like it was before. So I'm going to multiply both sides by x. All right. So I get x times the sine of 35 equals 8.4. And then I divide out both sides by sine 35. And your calculator knows what the sine of 35 is. So we'll use that in just a second. All right, so x. So now we take out our calculator, and this is what we work out. Okay, so 8.4 divided by the sine of 35, that gives approximately 14.6. And there we go. So it's just like with the tangent ratio, but we're just using a different side, so we have to use, instead of tan, the sine ratio. Next, I have another right triangle here. This is my theta. It's 38 degrees. The opposite, okay, it is not given, nor are we asked to find it. X, that is the adjacent, and that is what we're trying to solve for. What's given down here, this is 4.7. Okay, that is the hypotenuse. This is the longest side. The triangle is just laying flat on the bottom. So which ratio do we use? Okay, we want the ratio that uses the hypotenuse, the adjacent, but not the opposite. Well, that's the cosine ratio. So let's set it up. The cosine of 38 degrees is the adjacent divided by the hypotenuse. Okay? All right. Let's multiply both sides by 4.7. This one's going to be easier than the last one. So those cancel. And so to get x, I just take 4.7 and multiply it by cos 38. So let's work that out. 4.7 times cosine 38. And I get approximately 3.7. Okay, now this should make sense. Okay, remember the hypotenuse is the longest of the three sides. Okay, so there's no way I can get a number bigger than 4.7. So I should get something slightly smaller, and I do. Here's our right triangle. Theta is 68 degrees. It's the adjacent we're trying to find. The opposite, okay, is not given, and we don't need it, so let's forget about that. And 14.9, that is the hypotenuse. So which ratio uses the adjacent and the hypotenuse, A and H? Okay, well, we get to use the cosine again. So we set it up. Cosine of 68 degrees equals adjacent divided by the hypotenuse. All right, let's solve for x. Okay, this is another one of the easier ones because x is not on the bottom this time, which is nice. And I'm getting a little messy here. I'm just going to squeeze that in. Okay. So these cancel. So I get x is equal to 14.9 times whatever the cosine of 68 degrees is. So now we can use our calculator. 14.9 times cos 68, and I get approximately 5 point, I'll go to the nearest hundredth this time, 5.58. Okay. And there we are. Let's do one more. Okay. We have a large theta this time. That's 82 degrees. We are given the opposite. Okay, so that's 10.3. And it's the hypotenuse we want to find. The adjacent is not given, nor do we want it. So we have to choose the right ratio. So which ratio uses the opposite and the hypotenuse? Okay, well, now we're back to using the sine ratio. So let's set it up. The sine of 82 degrees is opposite divided by the hypotenuse. Okay, so that is actually set up exactly like this one. And I'm actually going to skip this time all this work because look at how I ended up getting my answer. Okay, all I ended up doing is effectively the sine of 82 and x just need to switch places because after all that's really what happened the first time here. So if you're not sure how I'm able to jump from this step to this step, don't worry about it. Okay, go back to doing the algebra step by step and you will get this same result. All right. So x is approximately, so I take 10.3 divided by the sine of 82 and I get 10.4. And I should get an answer bigger because after all the hypotenuse is the biggest side, so it has to be bigger than 10.3. Right? So again, just to recap, this is the original setup, and I just skipped all the algebra here, okay, but it's the exact same thing as over here, but the end result, you could see these two numbers just swapped in the end. So there we go.